I'm Dave Johnson. I'm the head of the IT division for Schneider Electric. And the IT division is, if you go back 10, 11 years, that's what used to be APC. So we take care of everything Schneider does in the data center in that business. We've just launched a 90 kilowatt and a 500 kilowatt design, a reference design for prefab as part of Uptime's tier program. And this gives a couple of convenient tools for the industry. For the 90 kilowatt, you're really talking about this sort of nice edge size solution, right? Because the edge is new and complicated, and there's a lot going on there. Customers want a simple, easy solution that they can deploy without having to think too much about the details. And this 90 kilowatt design gives us that. On the 500 kilowatt side, this becomes a nice building block for bigger data centers. So you have whether you're just building a 500 kilowatt data center or a multi-megawatt data center, it's a good building block size. This gives us that. It speeds up a lot of things, gives us a lot of quality because with prefab you can do more things in the factory. So you get the benefit of speed, and you get a better quality also when you do things in the factory. These are not shipping containers, right? This is one of the fallacies that you hear sometimes about prefab, or you get this image of this ugly, rusty old container. These are absolutely not rusty old containers. You can order a prefab solution in a ISO container, but oftentimes we see these as skids. They're deployed inside of other existing buildings. Or they've got a different kind of enclosure that may be in the same size range of a ISO container, but not the same aesthetic. The enclosures we might build would be, since you mentioned it, I would say more aesthetically pleasing. They look better, but they're also more optimized for footprint. So if you think about how many racks can I get in a module? What's the ideal shipping dimensions and weight? Will my switchgear, UPS, my mechanical and electrical equipment fit inside? And if I have some flexibility beyond the ISO container, then I can optimize it. That's really the more important part. In general, we're seeing a move to lower tier designs anyway, because we're trying to make things less expensive, we're trying to make things more flexible, we're trying to solve the limits of supply, the capacity build-outs that we have in our industry. And if I pull back a little bit on the tier ratings, and I rely more on resiliency from failover, from the software layer, I can pull back on the tiers. Now, the 90 kilowatt tier 2, we talked about that being something for the edge. And tier 2 honestly represents an upgrade from most situations you see at the edge. We would argue that ultimately the resilience that you see at the edge should be similar, if not equal, to the resilience you see in a large data center. The whole equation is important from a customer standpoint. The edge computing solutions just as critical as in the future as the central cloud data center. So that's got to be resilient as well. But tier 2 is an uplift from that. Tier 3 is practically the highest level of interest from our customer base. So I think tier ratings are still valuable because first, we don't have a lot of substitutes that are any better. There have been many attempts at this. And honestly, a lot of the elements in the current tier system are still valid. There are some limitations. There are some dynamics in data centers, mostly around resilience in the software layers that aren't comprehended. But I think there's an opportunity for other tools or other systems, other ratings, to kind of grade ourselves there. But we're not moving to a world where software is taking care of all of our problems yet. We see a very slow evolution in customers moving from a pure 2N environment or a tier 4, interest in tier 4 as an ideal standard. So it's been so slow as we move into tier 3 and tier 2, and the sort of elements in those designs allude to, they're still very relevant. This morning, Uber talked about the need for data centers in 5 megawatt chunks, and we just talked about 500 kilowatt chunks. Well, there is a very easy way to do this. This is through reference designs in 5 megawatt chunks. We absolutely embrace this and already do some of this. It's just that now you're talking about scaling up the size of some of the equipment. You may be using multiple pieces of equipment instead of just one of each kind in a smaller design. But absolutely, it's the right thing to do for that kind of scale application to think about 5 megawatt chunk size.